Hey guys, welcome to the channel. So today we are going to be making a simple trainer for this simple CNN model that we made in the previous video on my channel. So there are a few changes to this model that I have made. Since we are going to be training this CNN model on MNIST dataset, our input size dimensions are going to be 28 cross 28 pixels, which means that we can keep this part the same for the 3 layers, and this actually becomes like a different. It goes from, that was 28, so this goes from 28 to 14.
The greatest VTuber that's ever lived.
And after that, this was set to 400 right here. We need to set this to 3136 because that was the dimensions that we were getting after doing this part. I actually checked that when I was doing this process, passing in some raw tensors at 28 cross 28 image size, and then we need to set this out for 10 values instead of 1 because it broke the model. Since MNIST dataset contains dataset for values between 0 to 10, so like we have the value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are 10 values, so we need 10 output layers for that, hence why we are using 10 right there. So those are the only changes that we need to make to this model. Now moving on to the trainer. So getting started with the trainer, this is a classic practice which we are going to be doing. So over here in this code, I am importing my CNN model from this simple CNN file right here. After that, we are importing torch, and from the torch visions library, we are importing the MNIST dataset, and we are importing transforms and then the data loaders. So this is a very basic setup that you need to do in every single model. Even in this trainer part right here, we have done model.to CUDA and other stuff. So we are basically going to implement this part inside this trainer. So now what we are going to be doing is we are going to be defining transform. So transform is equal to transform.compose, and then inside of that we are going to do transforms dot to tensor, and after that we are going to be doing transforms dot normalize, and we need to do 0.5 comma 0.5. So we are setting up these values right here. That's going to be our mean, and this is going to be our standard deviation for each pixel. After that, we are going to be loading the data. So our data is going to be train data is equal to MNIST root is equal to dot slash data, and train is equal to true, comma transform is equal to transform. Yep, there we go. Transform is equal to transform. Now we need to load this into a data loader. We could directly train the model without using the data loader, but that would train the model on the CPU. So instead, since we are going to be training this model on the GPU as we are using it right here, after making the train data set, we are going to be making a data loader. So our data loader is going to be train loader is equal to data loader train data batch size is going to be 1000 images per batch, and shuffle is going to be true. So what this will essentially do is whenever we are taking an image from this dataset, it's going to be randomly mixed. So the model does not realize how to copy the patterns. It essentially learns instead. So now we are going to be setting our epochs. So epochs is equal to 5. We are going to be training this model for 5 epochs. So we are going to do for I in range epochs, and for image comma label in train data loader, we are going to do image dot to device label dot to device. And now after this we are going to start the trainer, but first of all we need to set it to 0. So we are going to do optim dot 0 gradient, and then we are going to generate the output. So output is going to be model image. Okay, so after generating the output we are going to pass it to the criterion to generate the loss. So we are going to do loss is equal to criterion out comma label. After that we are going to do loss dot backward optim dot step, and after that we are going to do print f total loss for the epoch it's going to be okay, so I forgot one very important part. So we also need to set this model for training mode. So we are going to do model dot train right here. So we are setting our model to the training mode so we can train this model, and in theory the code should be complete. Now let's try to run it. Oh flip,
The greatest VTuber that's ever lived.
okay, so guys, I forgot to add one line. So we are going to do image is equal to image dot to device label is equal to label dot to device. It was my bad, my mistake, I apologize. Now the code should hopefully work properly without any errors. So as you can see, now that the training has been completed, we can clearly see that the loss has dropped down to 4.7834, and this is how you can train your own simple CNN model. In order to run this model, you can pass in an input and then check the output. I'm not gonna show that part. Thank you all so much for watching. Do make sure to like, comment and subscribe. Please tell me down in the comment what would you like to see in the next video, and peace out.